Welcome to the deep dive. Today we are getting really specific, looking at a component that can honestly make or break a professional installation.
High performance bulk cable.
Exactly. We're doing a technical look at the Kramer BC-3X2T7S-100M. It's a 14 conductor presentation, or VGA, bulk cable.
And it comes on a big 100-meter reel.
Yeah, and that's the key. Our mission here is to figure out how the design of this one cable ensures you get a crystal clear signal over that huge distance. So, okay, let's unpack it. What are all those 14 conductors actually doing inside? I mean, we all know what a 15-pin VGA connector is, but what's the breakdown here?
Well, you can almost think of it as a little ecosystem in there. It's designed to handle a bunch of different signals all at once.
Okay.
The three most obvious ones are the mini coaxes. You'll see them color-coded red, green, and blue.
For the RGB video signal?
Yep, that's the heavy lifting for the analog video.
Yeah.
But then you also have two shielded pairs.
And what are they for?
That's usually for the DDC, the display data channel. It's how the monitor and the source talk to each other.
Oh, okay, so they can agree on resolution and all that.
Exactly. And then you're left with 7 single strands. Those handle things like your horizontal and vertical sync and really critical grounding paths to keep the signal stable. All 14 have to be working perfectly.
That makes a lot of sense. So the complexity is definitely there for a reason, but that signal is useless without, proper protection. Let's talk about the physical stuff, the armor.
Right.
The spec sheet highlights the 26 AWG center conductor and a dual shield design. It says a copper braid and an aluminum mylar foil. So hold on. If 26 AWG is better, why do we still see so many cheaper 28 AWG versions out there?
It's all about cost versus performance. It's a trade-off.
Okay.
The 26-gauge wire is just physically thicker. It lowers the cable's resistance and capacitance. And that reduction in signal loss is what lets you support higher resolutions and, more importantly, those really long distances.
Like the 100 meters we're talking about here.
Exactly. And that dual shielding you mentioned, that's the mechanical guarantee that the cable holds its 75 ohm impedance across the whole run. If that impedance drifts, you get reflections.
And reflections mean ghosting or smearing on the screen.
You got it.
Okay, so the ultimate test for distance is attenuation, right? The signal loss. And the data we have here is pretty eye-opening.
It really is.
Attenuation is only Manic of 5.7 dB at 100 millihertz, which seems great. But then it just plummets to Natico's 14.0 dB at 400 millihertz. That's a huge drop-off.
And that curve, that drop, is probably the single most important thing an installer needs to know.
Why is that?
Because it tells you the cable's practical limit. 100 millihertz, that generally covers something like 1080p. This cable's fantastic for that.
Right.
But once you start pushing into that 400 millihertz range for super high-end resolutions, that Natica 14 dB drop means the signal's likely going to fail at 100 meters.
So you'd get color loss or it just wouldn't work at all.
Yep. You absolutely need a signal booster or some kind of active equalization to make that work. Knowing that curve ahead of time dictates the entire system design.
And that kind of detail is what makes it a professional product. I also see it meets regulatory stuff like UL-CL2 and RoHS. Why is that CL2 rating so important?
CL2 is a fire safety rating. It means it's safe for in-wall installation in commercial buildings.
Yeah.
In a lot of places, that's not optional. It's actually required by building code.
Got it. It's a non-negotiable for pro jobs.
And things like RoHS and TAA compliance just confirm it's suitable for large-scale government or corporate projects.
So the big takeaway here seems to be that professional cable performance isn't magic. It's just these incredibly specific details. The thicker 26 AWG wire, the layered shielding, the right insulation, all of it engineered to keep that 75 ohm impedance stable.
Which brings up a really important question, doesn't it? I mean, this cable is listed today at around $552. It comes with a warranty and lifetime support. So how do you weigh that cost, that guaranteed technical compliance, against a cheaper standard cable?
Yeah.
It's really the difference between what's on paper and what actually works reliably 6 months down the line.
Avoiding that expensive service call.
That's the value.
Absolutely. So a final thought for you. Next time you see a simple 15-pin connector, just think about those 14 tiny engineered conductors and layers of shielding inside, all working to make sure a signal gets where it's going, even if it's 328 feet away.